Hello friends, this is Brajesh Kumar Jha. I welcome you all on my YouTube channel Mathematics for All. So in this series we are going to discuss about the fifth question from the topic sequence and series, which is related to complex analysis. So in the sequence, this fifth question again we are going to solve related to radius of convergence. So in that case, we can understand the most of the questions are asked in examination related to radius of convergence of the power series. So that you must remember. If you are good in solving such problem, then definitely you can solve one questions from sequence and series in CSIR NET or GATE examination. So today we have selected here CSIR date December 2011, and the question that asks. So in this question again we can see the question related to power series and the radius of convergence that we require to find. So the question given here, consider the power series that is an summation a n z to the power n, and n is greater than is equals to 1. Where n is what? It is the number of divisor of n to the power 50. Then the radius of convergence of this series summation a n zn would be. So options are 1, 50, 1 by 50 and D. D is 0. So in such questions, first we define the what number of divisors of n if we required. So what we do here, we know that what we can write here symbolically dn is approximately equals to n for large n, where dn is what? Dn is the number of divisors of n. Number of divisors of n that we know. So in that case, if we talk about the radius of convergence of the power series of a power series, that we can write here the summation d n to the power 50 z to the power n is greater than is equals to 1. So in that case, it will be the same to the radius of convergence of the summation n to the power 50 and z to the power n for n is greater than is equals to 1. So by having such logic, if we talk about an will be what? N to the power 50. So after this is the first part that we require to get an. So after defining an, it will be easy to get the radius of convergence. So by formula, it is 1 upon r is equals to limit n tends to infinity an plus 1 upon an. In some other books, supremum of that given here. So it will be equals to limit n tends to infinity. An plus 1 will be what? N plus 1 power 50 and n to the power 50. So if you take the division here, it will be 1 plus 1 by n and power 15. So as n tends to infinity, it is going to be 1. So I write here first limit n tends to infinity, and it will be what? 1 plus 1 by n power 50. So result is 1. So in that case, the r will be what? 1. So the radius of convergence of the power series, it will be 1 for both the series. So your option A is the correct option. So in upcoming questions, again we can see the radius of convergence. So that you must remember, you must be good in solving the questions related to radius of convergence. So thank you for watching this video. So you can like it if you are new, so do not forget to subscribe our channel, and if you like, you can share with your friends on social media. Once again, thank you for watching this video.